ഈ കാര്യത്തിൽ ഈ നാട്ടുകാർ
Hello everyone, good evening.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Okay, so today we have solved the session for week 7. So can you all just go to joinpd.com and enter the code shown on your screen? Okay, so as usual, just keep a notebook and a pen along with you to solve the problem that will be shown on your screen. For every question, you will be given 5 to 10 minutes, and you have to enter your answers in only in joinpd.com. There will be an option you will see to input your answers. If you're using laptop or desktop, the view will be something as shown in the left side of your screen. And if you're using mobile, it will be as shown in the right side of the screen. You have to click on that green button answer question and just input your answers. Okay. Moving forward. Yeah. Okay, so let's start with some basic concepts today that were covered in week 7. So one thing is the random experiment. So random experiment is an experiment whose outcome is not predictable with certainty, but we know that it would be something within this. Like if I'm tossing a coin, I don't know what would be my outcome, but I know that it would be either head or tail. So that's something we call random experiment. Sample space is a collection of all possible outcomes, like referring to the tossing a coin example. So all considering all my possible outcomes as a set, that is heads and tails, it would be my sample space. Events are outcomes or any combination of outcomes, or in other terms, you can say any subset of sample space is called an event. So in general, consider let's say we are rolling a die. So the possible outcomes for the sample space would be either 1, 2, 3, 4 up to 6, right? So suppose if I consider any subset of this big set, 1, 2, so on up to 6, let's suppose 1, 2, 3. So that would be an event. 2, 4, 6, that would be another event. So all the possible subset that you can make of it would be a event. And subset, so subset is any two events are said to be a subset of each other if they are contained in each other. Suppose consider an event that you will get a, let me just write it. So suppose rolling a die, our sample space was this, right? Let's say my event A is that I would get any of this, or this is the subset of sample space. Suppose event B is this. So you can see that event B is contained in event A, right? So in other words, we can say that B is a subset of it. Is it clear till now, everyone?
Yes, sir.
Okay, now moving forward to it, consider the following experiments. So we are giving you 3 experiments. One is you have to select a family out of a given group of families. So consider a group of families out of which you are randomly selecting a family. This is your first experiment. Second experiment is you from a deck of playing cards, you are selecting up any card randomly. And the third one is you are rolling a die and noting down its outcome. You have to identify which of the following is a random experiment.
Can I have the URL where we are supposed to enter IJFPWV?
Okay, yeah, just go to joinpd.com, typing it in chat as well.
Apologies, my history got deleted. That's why I was unable to find that. So yeah, got it. Thank you.
Yeah, so I have typed it in the chat also. You all can go and if you input your answers in joinpd.com, it's also helpful for us to get an idea of like how much you are clear with the concepts and what changes are to be made and everything.
Hello, sir.
Yes. Hello.
Hello, sir.
Yes. Hello.
Sir, I entered the code in PureTech, but still it's not opening.
Have you entered the right code? IJF.
Yes, sir. Twice I entered, still it's not opening.
Okay, so you went to joinpd.com, right?
Yes, sir.
You entered the code IJF. Can you refresh and try to enter again? So, for me.
Okay, sir. I try.
Okay, so let's move to the solution part of it. So that, okay, so majority of you have entered all of the above, one each for this. Okay. So yeah, so as we discussed above in the previous slides, the random experiment is the one where we don't know what would be the outcome, but we know that it would be any of these possible outcomes, right? So by its definition, all A, B, C are random experiment. Because in experiment A, yeah, we know that any family I'm selecting within will be one of the family in the given group. So I know that my possible outcomes, but I don't know what will be the outcome when I do it, right? Similarly, when I'm selecting a card from a pack of playing card, I know that the selected card would be one of these cards in my deck, but I don't know which one exactly would it be. Similarly, in rolling a die, as discussed earlier, we know that it would be any of these 6 numbers, but we don't know exactly which one it would be, right? Any doubt in this? Anyone? Shall we proceed further?
Yes, sir.
Yes, sir.
Excuse me.
Yes.
So can you give an example for non-random experiment?
Okay, so non-random experiment are basically called as deterministic experiment. Suppose you have an object, consider an object, let's say a car, it's moving with a speed of 50 kilometer per hour,
Okay.
constant speed. After 4 hours, the distance traveled would be 200 kilometers, right? And that's the only thing possible. That's with certainty we know that after 4 hours, the car would be 200 kilometers away from its initial position, right?
Yeah.
So that's something we are sure of. So such kind of experiment are non-random, where we are sure about what will be the outcome.
Then the probability would be always 1.
Always one, yeah. Probability of that after 4 hours far would be 200 kilometer away from its initial position. Yeah, it's 1, right? Because we know that would exactly happen. It's constantly moving at this speed for 4 hours.
We are certain about the experiment.
Yeah. Whenever we are not certain, we consider it to be a random and try to assign probabilities and see what all are the possible outcomes we could have.
Okay, I got it.
Okay, moving further. Okay, so this is an experiment where a guy named Ramesh is throwing 2 dice and he gave the following statements. Okay, so his first statement is there are 5 ways of getting the sum of number 5. Okay, so I'm rolling 2 dice. So if I add the numbers which appeared on each of the die, I should get 5. So he's saying that there are actually 5 ways of getting this. Second statement is that this experiment is not a random experiment. And the third statement is getting the sum of 12 is an event. So which of the following statement is true? You have to identify of these 3.
Sir, this is a radio button, and if I thought that 2 options are correct, then
Only one of them will be correct in this question.
okay.
It's MCQ.
Sir, only give the option. There is no submit button.
Yeah, there is no submit button. As soon as you select or input any number, it would get stored.
Okay.
So yeah. Okay, so moving to solution part. Okay, so okay, one is not still clear with the terms. Statement 3 most of. Okay, so moving on to solution part first. So number of ways to get 5 as the sum of number on 2 dice. So on how many ways I can get number of sum of 5 on 2 dice? It's I get 1 on my die 1 and 4 on die 2, right? Another way is I get 2 on my first die and 3 on my second die. And similarly, if I get 3 on my first die and 2 on second die, again the sum would be 5. And if I get 4 on my first die and 1 on my second die, again the sum would be 5. So there are a total of 4 ways to get. So statement 1 is incorrect. In statement 1, he is stating that there are 5 ways of getting the sum of 5, right? From the definition of a random experiment, yeah. So we know that it is a random experiment because we know only the possible outcomes, but we don't know which one will exactly appear after rolling out 2 dice, right? Third thing, getting a sum of 12 is an event. Yes, it is one of the sample space subset, right? Subset of sample space. So it is an event. Okay. Any doubt in this? Like,
Yes, sir. In option,
Yeah.
first option, there are 5 ways of getting the sum of 5. I know that option is wrong, but one quick query: how to find the 5 ways of getting sum of 5 in terms of formulas like combination 5C1 into 5C1 into 2, right? Correct me if I'm wrong, sir.
how you
Uh,
saying 5C, 5C?
because we can choose 5C1, we can obtain 5 in for the first die it's 5C1, and for the second die it's also 5C1.
No, not 5C1. See, you have to obtain the sum of 5, right?
Yes, sir.
Right. So I would obtain.
Okay, okay, my bad, sir. I got it wrong, sir. Sorry, I got it now.
Okay.
I got it. Yeah, sir. Thank you.
Anyone?
sir,
Yeah.
Sum of 12 means it will be 6 comma 6, no?
Yeah, 6,6. Yeah.
Okay.
So yeah, someone said that he's not clear with the terms also. So he or she can ask the query. Are you all clear with the first two questions? Okay. Let's proceed further. Okay. Okay. Suppose now we are rolling two unbiased die. So by now I think you are aware of unbiased dice. Unbiased dice means getting each outcome has equal probability of being there. Suppose I am rolling an unbiased die. So for each number, the probability would be 1/6. If I am rolling an unbiased coin, then for head it would be 1/2. For tail it would be 1/2. So for each possible outcome, the same probability would be assigned. So you have to find the probability that both the dice show the same number. Okay, let's move to the solution part. Before that, let's see. Okay, someone is entering probability greater than 15. Okay. See, so total number of outcomes, like number of elements in our sample space would be 36, right? So if you want to know what all 36 outcome would be, so all possible outcome could be I got 1 on my both the dice, right? 1 on my first die and 2 on my second die. Similarly, 1 on my first die and 3 on the second die. Similarly, 1 on my first die and 6 on the second die, right? Similarly,
Yes.
all these possibilities we would have. So in general, if you count it all, there are total of
6 ways.
36 possibilities, right?
Yes, sir.
While my favorable outcomes would be,
6.
and those 6 would be, I need to get the same number on both the dice, right?
Yes, sir.
1,1.
Which is
2, 2, 3,
these 6, right?
yes, sir.
So my probability that I get same number on both the dice would be 6 over
6 divided by 36.
right? 1 by 6.
0.17.
Yeah, which is nothing but 0.167. Rounding out to 2 would be 1.17, right? Is it clear with everyone or any doubt in this?
Sir, to find total number of possibilities, we can use permutation or combination as well, na? Like formula.
Yeah, you can use for, if I'm rolling 4 or 5 dice, in that case you must use these things. Here you can count, but yeah, you are using permutation. It's good. Yeah, it would save some time. Okay, moving further. Okay, again the same experiment we are doing. We are rolling 2 unbiased dice. We have to find out the probability that the first die shows 6. Okay, so condition is only on the first die. The first die should show the 6, irrespective of what number on second die.
Sir, can you one time please also tell how to solve using combination?
So, okay, yeah, this question we will do.
Because in a higher number of dice it will be helpful.
Okay, so for this question, we will also do by permutation combination. We will see. Okay, let's move to the solution part. So, okay, we had very close number on 0.16 again. So see,
Same, sir.
we already know that total number of possible outcomes we have is 36. So favorable cases are only these 6 cases: 6(1), 6(2), 6(3), so on up to 6(6), right?
Yes, sir. Number of favorable outcomes, sir. 6.
If you want to do it using permutation combination, so first for total number of ways, right? So we know that on die 1, any of the 6 number can come, right? From 1, 2, 3, 4, 5, 6, right?
Right, sir.
So total number of ways of first die is 6. For
6.
second also it's 6, right?
Yes.
Total number of ways is 36.
36.
Now in favorable cases, we have a condition that on the first die we should have a 6, right? The
Yes.
number of possibilities for die 1 is only 1. While on the second die, any of the 6 can come.
6. Yes, sir.
Favorable
And
cases.
next will be 6 and 2, sir.
So the probability that I get 6 on my first die is 6/36, right? That's how you can also apply your weak 5-6 conceptual knowledge over here. Any doubt till now, anyone? Before we proceed further.
Yes, sir.
Okay, so yeah, it's again the same question, but the thing you have to find is kind of different. Here you have to find a total number. Okay, you have to find the probability that the sum of number on the 2 dice is greater than 8. So one thing to notice, it is greater than 8. It's not greater than or equal to 8. That's the common mistake that students make. So make a note of it, it's greater than 8.
Done, sir.
Okay, so yeah, let's see the responses first. So again, we know that total number of possible outcomes are 36, right? So, and the only problem was we have to find the favorable number of cases that we have. So this, if you look at it, there are a total of 10 cases where the sum is greater than 8. So
Greater than 8, sir.
probability would be 10 over 36, right? Is it clear till question 3? Anyone, any doubt before we proceed further to next concepts? Okay, so proceeding further. Okay, so now let's assume that as you have done some experiments, okay, and you have a sample space. Out of that sample space, you have made 3 events, A, B, and C. So probability that event C will occur is 0.2. Probability that A union B means either A or B occurs. It is 0.5. And probability that either of A, B, C occur is 0.6. So you have to find the value of probability A union B whole intersection with C. So you can try using additional rule of probability and all those formula, but the best approach would be, I think, the Venn diagram. So you can also approach by that. It would save time in such questions. Okay, so I'm increasing the timer. I can see that a lot of you have not done till yet. So just increasing the timer in case you are attempting.
Done, sir.
Okay, let's move to the solution part. Okay. Okay. So before moving to theoretical solving, let's try to do it by Venn diagram. So what all things are known to us? Probability of C is, I think, 0.2, right? Probability of A union B is 0.5. Probability of union of all the three events is 0.6, right? Now suppose this is our complete sample space. And okay, let's just make a bigger one. Okay, consider it to be your sample space. And the three event, let's say this is event A. This is event B, right?
Yes, sir.
This is event C. Let me just mark it A, B, and C.
So middle part is 0.6.
No, it's A union B union C, right? It makes
Yeah.
this complete.
Yes.
That middle part would be difference.
This complete area, right? Union means either of them occurs.
Yes, yes. I'm talking about ABC.
So this is 0.6, right? This complete area we know, right?
Yes, 0.6.
We
So
use
from
this.
A union B union C, we can minus 0.5 A union B.
A union B is given, right? It's 0.5 given in the question. This is the value, sure. See, A
Sir,
union B is
I
given
can
0.5.
shade the area what question is asking by a Venn diagram,
Okay,
but I can't solve it further.
okay, we will do. So A union B would be, what area would be A union B? You know,
Sir, whole A and B circle enclosed.
right? This.
Yeah. Yes. Along with B as well.
Yeah. So this complete region is A union B, right?
Yes, sir.
Okay, and we know that yellow part is 0.5 and our light blue part is 0.6, right?
Right, sir.
Yes, sir.
The next is, let me use this color. Probability of C. It is 0.2. So C would be only this circle, right?
Yes, sir. C whole circle 0.2.
Okay. Now I could be okay. See, this yellow region is 0.5, right?
Right, sir.
And this light blue region is 0.6, right? Complete.
Yeah,
Right,
yeah,
sir.
right, sir.
So if I subtract the two, so only region left would be this one.
Only
Yes.
C.
Yes, sir.
C.
It's only C, right?
Yes, only C.
Yes, sir.
Nothing
Only red region.
with A and B, right? So
Right, sir.
probability of this red region would be 0.1.
0.1, sir.
Yes, sir.
Yes, sir.
Let me just mark it. Okay, so this region is 0.1, right? And we also know that this complete area, right? Just complete green area, it's 0.2 purple region, right?
Right, sir.
So if I subtract this 0.1 from this complete C circle,
And we can get required.
0.1.
so I get my this area,
Yes, sir.
Yes.
Which is asking. Yes, sir.
it is 0.1, right? And
Yes,
you have
0.1.
you have to find probability of A union B intersection with C,
Which is C.
which is nothing but this area, right?
Yes.
Right, sir.
So it's 0.1. Everyone clear with this or any doubt in this?
Yes, sir.
Yes, sir.
Sir, the else way of solving this?
Elsewhere, it's gonna be a bit complicated. You can keep it here. So not that much complicated, but yeah, it's gonna take some time. So we know probability of C, we know probability of A union B, right? And we know the union of 3. If I do it over here, we just
Sir, we can put it in a formula, sir. That formula. Probability of A plus probability of P minus A intersection B, sir.
yeah, but that formula I think is not covered in lectures, right? To do that. See, so we have to find this thing, right? A union B intersection with C, right? I am assuming A union B to be capital D, another even D. Okay. So in general, what I have to find is D intersection C, right? And this part I can write it as probability of D union C. Clear till this step?
Yes, sir.
Yes, sir.
Now using the additional rule of probability, I can write it as right. So
Yes,
probability of D is nothing but this 0.5 plus probability of C is 0.2 minus this thing we have to find, and we know this, right? So it's nothing but 0.1. It is a bit time. You will see one question in tutorial also where this theoretical solution is done. But if you do that by Venn diagram, it will be pretty easy. So Venn diagram can sometimes save you a lot in terms of time. Any doubt in this question? Like till this question, you can say. Or shall we proceed further?
So just show that Venn diagram once again.
I have to draw it. So Venn diagram was something like this was our complete sample space. Okay. And we have 3 events A, B, and C, right? Things which were given to us is it is 0.2, it is 0.5, and it is 0.6, right? So 0.6 is not A union B union C would be this complete region, right? Complete A, complete B, and complete C, right? the next thing was given to us that probability of C is 0.2. Probability of A union B is 0.5. So A union B was nothing but this area, right? So the leftover region, okay. So we know that purple region is 0.5 and this complete blue is 0.6. So if you notice, this region would be 0.6 minus 0.5, right? Who was asking this question?
Yes, sir. Sir, I
So-
understood. I just want to see that diagram only.
Okay. So I'm wrong over here. The next thing which was given to us is probability of C is 0.2. So this probability was given us to be 0.2. And we know this complete is 0.2 and this region is 0.1. So we got this region to be 0.1, subtracting. So that's the required probability. Right? Is it clear now?
Yeah, yes, sir.
Move it further. Okay. So it's the same question. Probability of C is given to you. Probability of A union B is given to you. Probability of A union B union C is also given to you. You have to find what is the value of complement of A union B union C.
Hello, sir.
Yes.
Sir, A union B union C is equal to 0.6 is given.
Yes.
But again in the question, what is the value of the
Complement.
Okay. Sorry.
Okay, moving to the solution part. Okay. Okay, so the complement is all that region which is not in that event. So if 0.6 is in the region of A union B union C, then the remaining 0.4 would be its complement, right? In other words, probability of complement of event is nothing but 1 minus probability of occurrence of that event. So here you know probability of A union B union C is 0.6. So its complement would be 1 minus 0.6, which is 0.4. Is it clear, everyone? Or any doubt in it?
Clear, sir.
Every time we take complement with respect to sample space.
Yeah.
Okay, sir.
Moving further to fifth question. Okay. An urn contains 6 white balls, 4 red balls, and 9 black balls. Okay. And now you are drawing 3 balls at random without replacement. It is given you are doing it without replacement. You have to find the probability that one is of each. Okay. One, you have drawn the ball of each color. One of white color, one of red, and one of black.
So can we solve this question with combination?
Yeah, that would be the, I think, time saving approach and the easiest way to do it. So you guys are now in week 7. So there was a reason why permutation combination was in week 5, 6. That you can use those concepts. Okay, let's move to the solution part. For that, okay, very wide responses. See the total number of ways you can select 3 balls of these 19. So have you noticed there are a total of 19 balls, 6 white, 4 red, and 9 black. So total of 19 balls you have, out of which you are drawing 3 balls at random. So 3 balls of these 19 you can do in 19 C3 ways, right? Which is nothing but 969 ways. Now you have to draw 1 ball of each color. So out of 6 white, you need to select 1. So it's 6C1 ways. Out of 4 red, you need to select 1. It's 4C1. And out of 9 black, you need to choose 1. It's 9C1 ways. So on computing, you will get your final answer to be something around 0.22. Any doubt in this? Anyone?
Sir, you have
Yeah.
written that the balls are not replaceable, right? So I applied as 6C1 divided by 19 into 4C1 divided by 18 into 9C1 divided by 17 into 6 because this can be arranged in 6 ways.
No. Okay.
So same
Can you repeat? Okay, so you applied 6C1 divided by
19
19. Okay.
multiplied by 4C1 and divided by 18.
18, right?
Yeah.
And then
Multiplied by 9C1 divided by 17 multiplied by 6 because it can be arranged in 6 ways.
yeah, that's the same thing. It's nothing but if you notice, it is nothing but 6. I can write it as 3 factorial, right?
Yes, sir. 3 factor.
And it is 19 factorial by 16 factorial, right? So I can also take this 3 over here, right? So it's nothing but 19C. So it's the same thing.
Hello, sir.
Yes.
Sir, can't we do this with one more way, but I'm not getting the answer. Like 6 by 19
Okay.
into 5 by 18
Okay.
into 4 by 17.
Okay.
Sir, what mistake I'm making here? I'm not understanding.
Okay. So here mistake is, see, in general, what you are saying is your total number of days is 19 into 18 into 17, right? And your favorable cases are 6 times 5 times 4, right? If we take into consideration your total cases are 19 into 18 into 17, right? So in this if I am getting white ball first, then red, then black, or black, red, white. These two are different cases, right?
Yes, sir.
So if these two are different cases, so in your numerator also it is possible that this red ball has come first. It would be 9, I think, right? You are this you in your case you have taken that white ball come first, then black, then right? But it is also possible that red come first,
Yes,
then
sir.
black, and then white. So you need to arrange these three also. These three can be arranged in 3 factorial ways, right?
3 factorial.
That's the missing part in the solution.
Sir, I'm interested to know if it was replacement with replacement in the question.
With replacement, right?
Yes,
Yeah,
sir.
with replacement, that's why we have 19 into 18 into 17 ways. If it had been with replacement, it would be 19 times 19 times 19. Total cases. Right?
Yes, sir.
Sir, I have did 1 by 6 into 1 by 4 and into 1 by 9. Out of 6, we choose 1, and out of 4, we choose 1. Like this got 0.004. So what I did wrong here, sir?
Okay, see, it's not like here you are doing this, you are just selecting one of the 6 balls, one of the 4 balls, and one of the 9 balls, right?
Yes.
But in general, if you see, you have a pool of 19 balls from which you are selecting 3 balls. So your total number of ways would not be this 6 into 4 into 9, would be 19C3, right?
Yeah. Yes.
That's where you forget this part. If the problem had been I had 6 white balls and I need to select one, then it would be 1 by 6. These are 3 individual problems we have taken: white, red ball, and black ball. You are selecting one, right? If this bag has 6 balls, you are selecting one ball which is already 1 by 6. But it's not the case. We have this combined in a big bag of 19 balls.
Yes, sir. Got it.
Anyone, any other doubt at this? Shall we proceed further?
So what would be the numerator in case of with replacement? Same.
Numerator would be same, right? Because I'm drawing only one ball, so without replacement won't make any difference to it. With or without replacement.
Only denominator will be 19.
Yeah. Okay, moving further, it's again the same one containing the same number of white, red, and black balls. And again, you are drawing 3 balls without replacement. You have to find the probability that, okay, no red color ball is there. So out of the 3 balls drawn, you either obtain the white colored ball or the black colored ball. No red colored ball should be there. So I'm extending the timers. I think 10, 15 of you guys are still doing it. So, finish. Do you guys need more time in this, or shall we proceed further?
We should proceed further.
I'll be just 30 seconds and then we'll proceed. Okay, so moving to solution part. See, in a norm, there are total of 19 balls, right? So total number of ways to draw 3 balls of these 19 was nothing but 19C3, right? Now, if I split this, like if we make a split, so there were 4 red balls, right? 6 white balls and 9 black balls, right? So now I have to select 3 balls for my favorable cases such that there is no red. No red means I need to select my 3 balls of these 15 only, right? Which I can do in C3. Okay. So probability would be nothing but favorable cases upon total number of cases. Is it clear, everyone?
Now I'm see I did it in the long about way. I feel really bad looking at it. I did probability for 1 white ball, 2 red. It's like 3 white, 3 red instead of doing this way.
Okay. Yeah. Basically, all these cases are covered in this 15C3, right?
Sir, can we do it in another way, like all the balls are red and then we subtracted?
Yeah, that would be also.
But the answer is coming different. If we are taking whole case, one white, 2 red, then 2 white, 1 black, 1 white,
Okay.
2 black.
Okay. None is of
In
red
that case,
color, right? Yeah. So you have to consider all the cases where you have
yes,
1
sir.
red, 2 red,
In
and
that
all the
there are
others.
4. It becomes 4 cases. 1 white, 2 black, 2 white, 1 black, 3 white, 0 black, and again 3 black. So in that case, the answer is coming 0.43, not 0.47.
It is coming 0.47 only. I did
It
that
will
like
come,
that.
yeah. It will be calculation error somewhere.
Hello, sir.
Yes.
Sir, can't we do it in this way? The earlier question answer was total ways of 3 balls. And
Yeah.
this question is asking not red ball, means we can subtract from total red balls probability. That will be
You have to subtract
4C1
all
upon
the cases.
19C3.
No, that's all 3 red balls, right? You also have to subtract the cases where you have 2 red balls and 1 red ball. Because those are also not in none of the red ball cases, right? You have to subtract these also, where you have 1 red ball, 2 red ball, or all 3 red balls, right?
Okay.
Clear, everyone? Or any other doubt? Okay, let's proceed further. Okay, so it's again the same scenario, same one. You have 6 white, 4 red, and 9 black balls. 3 balls are drawn. Okay, it's again without replacement. It's not written, but yeah, I think it's missing, but yeah, it is without replacement. You have to find the probability that at least one ball is white.
So without replacement, meaning here is like we are drawing ball in one go.
Without replacement means you are drawing one ball and you are not putting it back in the on. So for the next draw, you have only 18 possibilities instead of 19.
Sir, is it again without replacement?
Yeah, it's again without replacement.
Okay, sir.
Excuse me, sir. Have you covered the previous question?
Can you repeat?
Have you covered the previous question?
Yeah, we have covered it.
I got disconnected, so I don't see that. Sir. I got it as 0.36.
It was 0.47. Okay, we will look at it again after this. Let's focus on this one.
Hello.
Yes.
If in the question it is not written whether it is with replacement or without replacement,
It should be written always. I missed it writing here. It's without
Okay.
replacement. Do you guys need more time or you can move to solution?
We can move to solution.
Solution, sir. Solution.
Okay. Check your responses. Okay. Okay. So we know that total number of cases. Okay, let's do it with this picture again. Wait. So see, we know that total number of cases is 19C3 again, right? Now we are interested in that at least one white ball should be there, right? Okay. So in other way, I can consider it as 1 minus probability of no white ball drawn, right? So if no white ball drawn, it means out of these 4 and this 9, out of these 13, I need to draw 3 balls. That is my favorable case. And total base is 19C3. So that's one way you can approach. Another approach would be you have to make cases that you have drawn 1 white ball, 2 white balls, and all 3 white balls. And then you have to simply add the.
Sir, in this case, the answer that came was 0.70, which is 0.01.
0.71 it's about.
So in the second case, the answer came was 0.70. Will it come in wrong category or correct category?
It would be same. Yeah, 0.70, 0.7 is too close. I think some minor round of error or maybe something could be there.
Yeah, in this category, it came as point.
Yeah, we are close. So 1 white ball. Okay, so if one of the ball is white, so 1 white ball can be drawn in 61 base, right? And you need the remaining 2 of these 30. So 13C2, right?
Yeah.
Then for 2 white balls,
Sir,
you have to draw. Yeah.
It is not like that case, 1 white, 1 red, and 1 black.
That would be you. It's like you are expanding these cases into a lot more, right?
Yes, sir. Like 1 right, like 1 white, and
that-
then 1 red, 1 black.
Yeah, you can do it also, but it will be time taking. If you can simply you can combine all these 3 cases into one, that you have only 1 white ball. And you can simply compute it. It's better not to split it more further, right? And then all the right. You can find it by this way also. It would be again 6C1, 4C1 for 8, 9C1. Then for 2 red, it would be 61 for 1 white and 4C2. Adding all these 3 will give you the same answer, but it's about the time saving thing. Why to split further, but when you can already compute this, right? Is it clear?
Why
Everyone?
we are
Yeah.
subtracting it from 1?
Okay, so I have to find the probability that at least one white ball should be there, right? At least one white ball means either one white ball or two white ball or all three are white balls, right? So
Yes, sir.
and in general, total possibilities are I can get 0 white ball, 1 white ball, 2 or 3 white balls, right? So if from total possibilities I subtract the 0 case, I will get for this 1, 2, 3, right? So total cases from total probability 1, I am subtracting the probability in which there are 0 white balls. In general,
So
no
for
white
zero
ball
white
is
ball, we need to
complement.
subtract it from 1.
Is it clear now?
Yes, sir.
Anyone, any other doubt? This shall we proceed?
Sir, I asked for previous question. I got the answer as 0.36. You said it was 0.47.
Yeah, it's 0.47.
I did it as 6C2 multiplied by 9C1 plus 6C1 multiplied by 9C2 divided by 19C2.
1 minute. Let me just write it up. Okay, how did you do?
6C2 multiplied by 9C1
Okay,
plus 6C1
okay,
into 9C2
okay,
whole divided by 19C3.
okay. But you have missed 2 cases here, right? One is you could have all the white balls, all red balls, all black balls. Sorry. Yes. These 2 are also possible cases. You have missed these cases. Okay, any doubt in question 5, anyone? Shall we proceed further? Okay.
So,
Yeah.
what if they ask 2 balls are white?
2 balls are white.
Yes, sir.
Okay. So we have a total pool of 19 balls, right? Out of which 6 are white, 4 red and 9 black, right? So total ways to draw 3 balls would be 19C3 only, right? That's clear, right? Total
Yes, sir.
basis. Now you are saying I need 2 white balls. So it means from this 6, I need to select 2, right? And from the remaining 13, I can select any one ball. So that's my favorable cases, right?
Yes, sir.
So probability of getting 2 white ball would be favorable cases divided by total cases, right?
Okay, sir.
Clear now?
Yes, sir. Thank
Sir,
you. Sir.
Yeah.
sir, was this explanation for at least 2 balls, 2 white balls? Because if the question was like, we need at least 2 white balls, then how would you do it?
Okay. At least 2 white balls, right?
Yes,
And
out of
at
3,
least
we need at least 2 white balls.
it means I should have either 2 white balls or 3 white balls, right? So I will
Yes.
first compute the probability of 2 white balls like we did right now, right? And probability of 3 white balls would be 6C3 over 19C3. So you simply add them up, right?
Okay, we add them. Okay, thanks.
Excuse me, sir.
Yes.
So how can we approach the same question if it is with replacement?
If it is with replacement, okay.
Yeah, I was having the same question. Thank you for asking.
At least 1 white ball, you are saying, right?
Yeah, yes, sir. Same question.
Okay, at least 1 white. 6 white balls we have, 4 red and 9 black. Okay. So probability that we need at least one white. I can write it as 1 minus probability, no white balls, right?
Yes, sir.
So
Yeah.
probability of no white. Okay, so for this we need to find. So total number of ways to draw 3 balls would be 19 times 19 times 19, because in each draw you have 19 possibilities, right?
Yes, sir. Yeah.
Now favorable cases would be, we need only from these 13 balls. So
Yeah.
at the first draw, I can draw any of the 13 balls, at the second also, at the third also. So it would be this.
Okay.
Okay.
Okay, sir. Thank you.
Sir, what if in case of at least it was at most?
At most one white ball means you have to consider case where there is 0 white ball and 1 white ball only. That's what at most means, right? I will add 2 cases, 0 white ball and 1 white ball case. Okay. Clear everyone? Or any other doubt in this? Okay, let's proceed further. Okay, so next question is that a person named Suresh, he applies for 2 jobs in firm X and Y. So probability of him being selected in firm X is 0.7. Probability that he will be rejected by firm Y is 0.5, which in general means that accepting at firm Y is also 0.5. The probability of at least one of his application being rejected is 0.6. So you need to find the probability that he will be selected in one of the firms. One of the firm means at either X or Y, any firm will work. He needs to be selected in one of the firm. For this, try to put this events into terms of union, intersection, and then see which part you have to compute. First, try to write what all information is given to you in terms of events and their probabilities.
Hello, sir.
Yes.
Well, we don't have to consider the case where he is selected in both the forms, right?
You can. It's still one of. It's still the case of one of the form, right?
Yes, yes.
So both can also be considered. Okay, let's move to the solution part to the wide variety of responses from your end. Okay, so we have considered two events A and B. So event A denotes that Suresh is selected in the form X, okay, and event B denotes that he is selected in the form Y. From the question, it is given that probability of A is 0.7. Probability that he will be selected by form X is 0.7, right? So this implies probability that he is rejected by form X is 0.3. Okay. Similarly, it is given that probability that he is rejected by form Y is 0.5. So probability that he is accepted by form Y will become 0.5, right? Next thing, it is given that probability that at least one of his application being rejected. At least one of his being rejected means either X rejected or Y rejected or both of them rejected, right? So it means probability of A complement union B complement is given to be 0.6, right? And if we use the form addition rule of probability, it would be probability of A complement plus B complement minus probability of A in complement intersection B complement. From here, you can compute the value of probability of A complement intersection B complement. And then it is asked probability that he will be selected in one of the two firms. So it is nothing but A union B. A union B is you can also find by doing 1 minus probability of A complement intersection B complement. So it is 0.8. Clear with, yeah.
I thought 0.6 is X union B whole bracket complement.
Okay, one minute.
Sir, can we can't calculate like a select.
Okay, let's just do it from here. Okay, so probability that he is selected by form X is 0.7, right?
And sir, if we keep probability from Y, it is 0.5 and X or Y, like then we can combine both 0.7 and 0.5.
Okay, let's try this. Okay, so this information is given to you, right? Probability that he is accepted by firm X, probability is selected by firm Y, right?
We can't do the like here P X union Y. It will be like either one or two. He will be selected by X or Y.
Yeah, we are doing that, right? X union Y. We have to find that. Okay. Next thing, it is given that probability of at least one of his application being rejected. So at least one rejection, right? It means that he is either rejected by firm X or by firm Y or by both, right? Which is nothing but rejection from firm X, union rejection from firm Y.
Sir, one quick question. Are these events are disjoint or joint?
X and Y, these are not disjoint, right?
They will be not disjoint, right?
Yeah, they will not be disjoint.
Why
They
are
have
we
some
finding
intersection.
union?
Sir, please go to the solution slide. I have one doubt.
Okay.
Solution slide, sir. Sir, in the last line, there is a PA union B is equal to 1 minus PA complement intersection B complement. Actually, I want to know the meaning of this event, PA complement intersection B complement.
Yeah, we are
That
coming to it.
both are rejected. What?
Yeah, both are rejected. That's what it would be. Both are rejected.
A complement union B complement means in both.
Either or. Could be both, right? Union means either X
Union,
rejected.
no. This is not union. It may be intersection.
See, union means either X reject or Y reject or both reject, right? That would be considered in this union, X complement union, Y complement, right? While in intersection, X complement intersection, Y intersection, it means both rejected, only this case. Okay. Okay. So clear till this step. Now we can use the addition rule of probability. Right? So it is 0.3 plus 0.5 minus this point. So from here we obtain this intersection part. It means he is rejected by both firm X and firm Y. It comes out to be 0.2, right? So now if we take a bit help of Venn diagram, consider it to be event X, event Y, right? So your X complement intersection Y complement would be all the region outside the circles, right? So your probability X union Y would be nothing but 1 minus all this blue region. So it is 0.8. That's what we have to find, right? Is selected in one of the forms. Clear, everyone? Or any doubt in this?
Sir, I have doubt in this.
Sir, I have a query on this.
Yeah.
So, like, it is selected by any of the firm. Can't we do this by selected by one into not selected by the other plus selected by the first one or not selected in the second?
No, you can't do this in that way because these are not independent events.
Or this also we cannot do that one minus rejected in both.
1 minus rejected in both. 1 minus rejected in both. Okay.
Like 0.3 into 0.8, 0.5.
That's what we are doing, right? 1 minus rejected in both.
Achha, okay.
Sir,
Yeah.
is the coverage of De Morgan's law there in this statistics?
Can you repeat?
Is De Morgan's law covered in this statistics?
Yeah, that's De Morgan's law we just used over here.
because you are used for Venn diagrams, so Venn diagrams are also known as well.
Hello, sir.
Your voice is very low. Can you speak a
Hello.
little louder? Yeah.
Hello. Hello. Sir, is there any other approach like tree approach is there? Can I solve this problem using tree approach?
Tree approach, yeah, you can use any approach. We will cover all these approaches mostly in week 8. But yeah, you can, if you know the tree approach, you can use it also. You can use any of the approaches. Siva.
Actually, I forgot, but I know there is a tree approach. But
Yeah, it's mainly used in the conditional probability thing and base theorem. For such simple problems, we can just use the addition law, probability, and De Morgan's law. These two things are.
So,
yeah.
So, like what I did was I took x complement means like x complement union y complement means he has been rejected in both.
Yeah. Union means rejected
Sorry.
in either.
Okay.
Yeah.
Actually that last step 0.3 plus 0.5 minus 0.6 we are actually calculating he is rejected in both.
Both. Yeah.
Yes, sir. So what I thought was like if he is rejected in both, we got 0.2. And I my 1 minus 0. So what I did was like 1 minus 0.2. So which means like I thought 0.8 is he is rejected in sorry he has been accepted in both A union B. What I thought was
A union B is either. Yeah. So you have misinterpreted union thing, right?
yes, sir. So but that Venn diagram which you made, I am unable to get that. So can you please explain that once again in the whiteboard?
Okay, so here we need to find X union Y, right?
Yes, sir.
We know the total probability of sample space is 1, right?
Yes, sir.
So if I subtract this blue region from this complete sample space, I will get the X union Y.
Yes, sir.
So probability of X union Y is nothing but 1 minus X complement intersection Y complement, this blue region,
So
right?
X union Y will also consider the case where in one firm he is accepted and in one firm he is rejected.
Yeah, that's fine. It's still selected in one of the forms, right?
So sir, this circle is only for rejection one, no? Rejected in X and rejected in Y. This circle.
That's acceptance. Outside circle is rejection.
Okay.
Circle X means accepted in reg, accepted in form X. Circle Y means accepted in form Y.
Okay.
That's what our aims are, right?
Yes, sir.
That's all.
So sir, that blue mark was given to us. We calculated green and X union Y using that blue mark.
Yeah, we subtracted the blue mark to get the X union Y.
Yes. Okay. So now clear, sir. Thank you, sir.
Okay, I think
1 second. So I do have. So what was given is for 0.6, if I consider A intersection B, where is when I say A intersection B, where he has been selected in both the
forms, right?
And the complement of it is what is given as 0.6. Is my understanding right?
Complement of A intersection B, you are saying.
Correct. So what I essentially get is 1 minus 0.6, that is 0.4. And
okay.
Using the same formula, if I consider what is asked is P probability of A union B.
Yes.
We already know probability of A. We already know probability of B. And
yeah.
By considering by considering 1 minus 0.6, I got
1 minus 0.6.
That is probability of A intersection.
Yeah, you can do like that also. Yeah. It is nothing but X intersection Y whole complement, right?
Correct. X intersection Y whole complement. I have subtracted from 1, so I got essentially 0.4.
Yeah, that's also you can do.
Thank you.
Good approach. Yeah. Okay, moving further. Okay, this is the last question, hopefully. So we have 5 numbers and 2 alphabets. Okay, considered all to be distinct, and they are to be placed next to each other for making a security password in a laptop. Okay. So we have 5 and numbers and 2 distinct alphabets. Consider all these to be distinct, no two are same. What is the probability that there are exactly 2 numbers between the 2 alphabets?
Sir, with replacement or without replacement? Hello?
There are only 7. You have to arrange. It's without replacement, obviously.
Sir, in this case, repetition is allowed or not? Excuse me, sir.
Yes.
Sir, in this case, repetition is allowed or not?
No, not allowed. No repetition, no replacement. Only these 7 you have to arrange.
What is the length of the password? Total length of the password? 7 digits.
7.
7.
All these 5 numbers and 2 alphabets to be used. Okay, so the question statement, for those who didn't understand, it's you have 5 numbers and 2 alphabets. So in general, you have 7 objects, you can say 5 number, 2 alphabets. And you have to place all these 7 next to each other. And you have to find the probability that in between 2 alphabets, there it is exactly 2 numbers. Okay? That's what the question statement exactly is. Okay, just one more minute. So those who are in between can just solve. Then we will move to solution. You can input the answer whatever you obtain. Okay, done with this, or you guys need more time? Anyone?
No, sir, we can get to the solution part so that we can switch to math.
Please solve it. I have Python class at it.
Okay. Anyone solving an in between? Need more time? Okay. Just okay. So let's just over. See, in general, you had 5 numbers and 2 alphabets, right? Let it be, let's say, A and B, let's assume. Okay? And you have 7 places in total where you have to arrange them. 7. Okay. So in how many ways can you arrange 7 objects at 7 places? It's 7
factorial.
Right? Yeah, 7. Now we need to find the, so that's our total cases, right? For favorable cases, we need to find the cases where you have 2 numbers between your alphabets, right? So we have to make cases for that. First case, let's say alphabet A is here and alphabet B is here. And remaining in between, we have numbers 1, 2, 3, 4, 5, right? Second case, A is at second place and B is at 4th place. And at all remaining 5, you have numbers, right? Yeah, so number of ways for this case would be 5 factorial, right? Because A and B is fixed and you are arranging 5 numbers, right? Similarly for this also. Next case is you can have A over here and B over here, right? And then you can arrange 5 numbers. 5 factorial ways. The last case also, you have A here and B at the last position, and you can arrange the 5 places in 5 factorial ways, right? So in total, you had 4 times 5 factorial ways till now. But A and B can also interchange, right? In that case also, I will have 2 numbers in between my 2 alphabets. So these are my favorable cases, right? Is it clear, everyone?
So, question, the wording of the question is not very clear because it is saying that alphabets are next to numbers.
Next to, it's saying that now are to be placed next to each other. So these are 7 objects which I am placing next to each other. That's what it means.
I also misinterpreted as 5 plus 2. 5
Sir,
alphabets, 2 numerics.
So to select 2 alphabets, first we have to choose it from 26
No,
letters.
you have specific 2 alphabets and you have specific 5 numbers.
So what I understood that like we have to first select 2 alphabets, then arrange them.
It's okay. So the wording can be improved for this question.
Sir, I have a query related to this question. Like
Yeah.
the other way that I have solved that, like there are 2 numbers between the alphabets. So I made the block of 4 having 2 alphabets at the outer side and 2 numbers in the inside. So the entire 4 block plus 3 can be arranged in a way of 4 factorial. But now the alphabets can also get arranged to 2 factorial multiplied, and internal 2 numbers can also get arranged. So this will go to 2 factorial. The 4 factorial into 2 factorial will be favorable.
No, but see, you have to also select which 2 numbers are going inside.
Into 5C2.
Right?
Achha, which, oh, okay, understood.
Okay, one last. Okay, so that's how you will get your final answer. You can go through it in the slides. Okay, just a quick question.
So what was the answer of earlier question?
It was 8/42, I think. I will show you after this.
Sir, I have a doubt in one of the practice assignments. Can I ask it after this?
Yeah, after this we will discuss. So that anyone who
Sir,
has any question can pop off. Yeah.
how I did the last question was I considered those 4 cases and then divided it by 7 combination 2. I got the
Yeah,
right
you
answer.
can do that. Yeah. So you are only considering 2 alphabets, right? You are not caring about other 5. You can also do that. It's possible to do that. Yeah, that's what written in the solution part is. The approach you are referring.
Questions over.
Yeah, questions over. That's it. That's the last.
Sir,
Feedback. Yeah.
so in previous question, like alphabets were fixed. So, sir, in total ways also the alphabets were not supposed to be chosen, na, sir? In total ways.
Yeah, those 5 numbers and those 2 alphabets were fixed. So, okay, what exactly the question was? Okay, if you do it. So, question was you have some 5 numbers. Okay, it could be any 5, but you are given that you have these 5 numbers. Let's say. Okay, and you have 2 alphabets. So, in total, you have these 7 objects, right?
Oh, yes, sir.
Now you have to place these 7 objects next to each other, right? Such,
Yes.
and you have to find the probability that there will be always 2 numbers between the alphabets, any 2 of these 5,
Yes.
right?
Yes.
So that was the question statement maybe. And the way we approached it, we made cases. Suppose alphabet A at the first place, then 2 gaps for numeric number, right? And then alphabet B at 4th place. We fixed A and B. Now remaining 5 numbers can be arranged at these 5 places in 5 factorial ways.
Yes, sir.
Another case could be my A is at 2nd place and B is at 5th place.
Yes, sir. Sir,
Again,
in this,
yeah.
So can we do it like we can make blocks like 3 are independent numbers and including alphabets and number between them as 1 block.
Yeah. Yeah.
So total we have 4 elements.
Yeah, you can
For
arrange
now.
it 4 factorial
So
ways.
first we will arrange all the 4 elements. After that we will arrange the A and B, which is 2 factorial.
Right.
And so the number between them, the left number between them will also be arranged in 2 factorial ways.
No, see, but these 2 numbers could be any of the 5, right?
Yes, sir.
So first you have to choose those 2 numbers which will go between A and B and then multiply the 2 factorial. Right?
Okay.
Sir, I have doubted the second last question.
Yes.
Clear, right?
Yes, sir. Yes, sir. So then for the 3 numbers also we have to arrange we have to choose it.
Yeah, see, 2 numbers goes there, right? Now you are left with
Yes.
3 numbers. So out of 3, you have to
3
select
C
one.
3 equals to
Yeah.
1. Yes.
That is right.
Sir, why are you multiplying with factorial 4?
Okay. So what he was saying is, he is saying that he is considering it to be one single block, 2 alphabets and 2 numbers in between. Okay.
Yes, sir.
And remaining 3. So all these 7 places you have, he is considering these 4 to be one single unit.
Okay.
So these 4 can be arranged in 4 factorial ways, right?
Yes, sir.
Now A and B can be interchanged in 2 ways.
Yes, sir.
Now out of 5 numbers, any 2 can go in between A and B, right?
So
So
the
first time I have chosen 2 numbers and then I have arranged them. Right?
Permutation, same permutation.
Yeah, 5 people. So that's how he has approached.
Sir, remaining numbers can also arrange in factorial 3 ways.
We have considered it in here, right? 4 factorial. These 3 numbers and this complete unit.
Okay, sir. Good.
Sir, I
Okay.
have doubt in second last question, the slide one.
This one.
So my doubt is, sir, if we take the complement of probability of at least one of the application being rejected, then answer will not come.
Can you speak a little louder? This is very low. Which complement you are referring? Hello.
So rejecting at any of the one form.
Rejecting at. Okay, rejection by any, right?
Yes, sir, rejection at.
So it is X complement union Y complement.
Yes, sir.
Yeah. So if you look at it by Venn diagram, suppose this is your X, this is Y. So X complement union Y complement would be, should I say, all this region, right? But is X complement would be this region, right?
Yes, sir.
But is Y complement? Y complement would be all this region, right?
Yes, sir.
So X complement union Y complement means all the region except X intersection Y, right?
Okay, okay.
So I can write it as 1 minus probability X intersection Y, right?
Sir, if theoretically we complement the whole bracket, sir, the union sign will change into intersection.
This thing you are saying, yeah,
Yes, sir.
you can write it as, and this union will become intersection. Okay, and if it had been intersection, it will change to union.
Okay, sir, understood.
Okay, anyone, anything else? What shall we discuss today?
Hello, sir.
Yes.
So, can you take one more session on week 6? Only week 6.
Only week 6. Okay.
Some practice questions are quite difficult.
Okay, we will conduct an on-demand session for this.
Okay, we will be notified for that.
They will be notified a day before it will be conducted. Or if it is conducted in the evening, you will be informed in the morning. Okay. By the way, what times is more comfortable for you guys for on-demand session? At what time?
After 8. 9. After 8. Not in
After 8
morning.
till night. Okay.
Yes, sir.
Okay, we will look into that schedule. Anyone?
Excuse me, sir.
Yeah.
I have doubt in practice assignment 7.1.
Okay. You have
Question 2. Question 2.
The question would be different for all of us. Let me just to MSQ. 7.1, I think we all will have different questions for it. Do you know the question statement?
So there are 10 multiple choice questions.
Okay, this one. Yeah.
Yes,
Okay.
sir.
Multiple select question here, right? More than one option, 4 options. So if a student chooses all correct option, then he she gets 4 marks. At least 16 marks, right? So see what happens is there are exactly 10 questions, right? 10 question means maximum marks is 40.
Yes, sir.
So for every question there are 4 marks. Okay, so what is the probability of getting any question correct in MSQ? In MCQ it's 1/4, right?
Yes, sir.
But in MSQ what happens is, suppose you have option A, B, C, D. So it is possible that only one of these options is correct, right? So there are 4 ways, but it is also possible to have 2 options correct, right?
Yes, sir.
2 options correct means any of the 2 of these 4 can be correct, which means 6 ways, right? Is it clear?
Yes, sir.
Okay, next is, it is possible that 3 of the 4 options are correct in MSQ. So any of the 3 of these 4 can be correct in 4 ways, right?
Yes,
Or
sir.
it is possible that all 4 options are correct. So it is 4C4, which is 1 way, right? So in total, there are 15 ways to answer an MSQ, right? I can select either 1 option or 2 option or 3, or I select all the 4.
Correct, sir.
Out of these 15, only 1 will be correct. So probability that I get any question correct is nothing but 1/15 in case of MSQ. While in MCQ, it was 1/4 only, right?
Yes, sir.
So to score at least 16 marks, it means I should get at least 4 out of 10 question correct, right?
Yes, sir.
Yeah. So one way is that you can approach by making cases where you get 4 correct plus 5 correct plus so on up to 10 correct, right? Or from 1 you can subtract those cases where you get 0 correct, 1 correct, 2 correct, or 3 correct, right?
Yes, sir.
Now you have to compute the probability for this. So for anyone, how will you find? Let's take 0 correct. 0 correct means for all the 10 questions I have answered incorrectly, right?
Yes.
1 correct means 1 correct. Out first, I have to select 1 question of these 10, which I can do in 10C1 ways, right?
Then what have you written before that? 14/15 raised to 10.
Answering all the 10 questions incorrect. 0 correct, right?
Sir, how did you get 14/15 raised to 10?
For answering any question correct, probability is 1/15, right? So probability of answering any question wrong is 14/15, right?
Yeah, sir.
So if I answered all the 10 questions incorrect, it would be 14
Yes, sir.
by
Yeah.
15 into 14/15, right? 10 times.
Yes, sir. Yeah.
So that's for 0 correct. For 1 correct, out of 10 question, I can answer any one of them correct, right? So first I need to select 1 question. So from the 10 question, I am selecting 1 question, right? I answered that question correctly, and remaining 9 question I am answering incorrect, right?
Yes, sir.
Similarly, for 2 correct, first I need to select 2 questions which I am answering correct. So from 10, I am selecting 2. For 2 correct, it's 1 by 15 squared, and for 8 incorrect, it would be this, right? Similarly, for 3 correct, you could go. I think it would be a lot of calculation in this.
Yes, sir, understood.
Okay, ignoring the calculation part, you understood the approach, right? How
Yes,
we are-
sir. I understood the logic.
Anything else? I think we can close. Go to. Okay, guys. Thank you, everyone. Good night.